For the first time since the 1980s, the green and golden bell frog will be in the wild in the ACT. Researchers at the University of Canberra have been breeding the frogs to withstand the deadly chytrid fungus, which is responsible for the decline and extinctions of hundreds of amphibian species. Now, one of the researchers is Associate Professor in Conservation Ecology, Simon Clulow, and he joins us now, having just released the frogs this morning. Dr. Clulow, can you tell us about that moment? It must have been exciting after all that hard work.
Yeah, it surely is. I can only really describe the feeling as quite surreal. I've actually worked on this species for around about 20 years, studying it where it managed to hang on sort of way down at the coast in very isolated pockets, and in my lab ever since. So the fact that we've now actually released it back to a region like the ACT where it's been extinct for nearly 50 years is just, it's quite a feeling, yeah.
Yeah, it's fantastic that we're getting the shot there and understanding what's happened this morning. And before we get into that, what happened all those decades ago to make this little frog that I know is dear to so many hearts, but that made it leave the area?
Yeah, it's a difficult one because unlike a lot of conservation problems that are focused on habitat loss and things like that, it's not been a habitat problem for a lot of these frogs. It's an invasive disease that emerged in the 1970s and 1980s and actually spread around the world. And it's responsible for the decline of at least about 500 species that we know of, and in fact the complete extinction of about 100 species. And it's a really intractable problem because it's not something that's easily eradicated. We can't see this pathogen that causes the disease. It lives in the water around us in these wetlands and in lots of host frog species that don't decline. So it's basically impossible to eradicate, and we've really had to develop solutions that allows the frogs to coexist with the pathogen, and that's taken, I think, a solid 15 years or more of research.
So what you've got in front of you there, as I understand it, is this modified wetland habitat you've got there in Canberra. Can you tell us about that?
Yeah, I can. So you can probably see in front of me there's actually a smaller wetland. We've created and dug this in, and we call them satellite ponds. So one thing that we observed, a decade or more ago, is that where this particular frog species hung on down at the coast, often it was associated with wetlands that had slightly elevated salinity. And we discovered that that is actually because the pathogen, the fungal disease, doesn't like that, whereas the frogs handle it okay. And so we're able to dig these in and manipulate the salinity without affecting the wetland behind us at all. And the frogs love to use them and breed in them, and it affords them some protection. The other thing, it was a student-led project, but there's been lots of observations also that the fungus doesn't like elevated temperatures over 25, 27 degrees Celsius. So we've developed these sort of hotspot structures, simple piles of black bricks under little greenhouses that the frogs also love to use. They hide in them. They love to bask and elevate their body temperature. That allows the frogs to get their body temperature over that critical threshold in the winter months, usually when the disease takes hold. And so it's these sorts of interventions that are giving hopefully will give the frogs the upper hand over the disease and enable them to coexist with the pathogen.
And so what happens from here in terms of monitoring this?
It's a great question. So we've actually today released another one of the prongs of research that we've investigated is a human health one, a way to actually essentially vaccinate and immunise the frogs, and we can do that by deliberately infecting them but clearing the infection before it gets severe, and that makes them more resistant. And so today we've released a lot of those immunised frogs into this wetland. We'll now go out. They're all microchipped, so we can follow them around. We can go out in the middle of the night in waders, do the calls to them, they call back, and we can catch them. And so we can actually monitor now their survival. We can swab them and determine the disease outcomes to see if they get the disease and whether it becomes deadly or they are able to survive and clear it, and really assess if our intervention strategies are going to work. And that's a real world first. A lot of this stuff has been developed in lab and mesocosm studies at universities over the past decade and a half. But now this is a first real-world test where we're trying to actually reintroduce a species that was lost almost 50 years ago.